In this video, we're going to look at radicals. What do they look like, and how do you simplify them? So a radical, whenever you see, most people kind of call this the square root, although technically this is called a radical. A radical has a base number on the inside. So let's just say we have x, some unknown number. This number on the inside has a power. If you don't see it, it's automatically a 1. If you do see it, obviously it'd be whatever we're seeing there. But a radical also has, and this is maybe the most important part of a radical, it has a little tiny number up here called an index. And this number here tells you how many of these items or how many of these numbers we have to have in order for it to get out of the radical. Like, for example, if I have the square root of 9, okay? So right here, there's an invisible number. We don't see it. It's automatically a 2. So this would mean, it's because it's a square root, this would mean that in order to reduce this, we would have to have some number to the second power. Well, 9 actually equals, so if I kind of write this again, there's an invisible 2 up here. 9 actually equals 3 to the second power. And that is going to be what we're going to use when we are reducing radicals. So the way I think of radicals is kind of like jail, all right? I hit on somebody's girlfriend, and then all of a sudden I'm in jail. It's an ugly situation. There's M for me. I'm in jail, and I go up to the jailer and I say, hey, I want to get out of jail. I'm stuck in this radical place. It's so awesome. But I want to get out. And the jailer says, that's great, but you have to have a certain number of tokens in order to get out of jail. And so I look up here in this little tiny window up here, and it has a number. So let's say it's a 4. That means that I have to have 4 exponents or 4 powers or 4 tokens in order to get out of jail. If I only have 3, and I go up to the jailer and say, hey, I want out, he's going to say, no, you need more. Okay, if I have 4 tokens, then I have exactly how many it takes, and I am now able to cancel this and get out of jail. So I'm able to get out, and I am no longer inside of that radical. Okay? The one interesting thing about this is that if I have too many, let's kind of get rid of, okay, if I have too many tokens, so this is really m times m times m times m, there's 4 of them, times another m. So if I was to technically write this out, this would be m to the 4th power times m to the 1 power, which means that this guy can get out of jail because he has exactly how many tokens it would take. So I have an m on the outside. But there's still an m on the inside that has 1 token. He doesn't have enough. He has to stay inside. So it would look something like this. So moral of the story, in order to simplify something with exponents inside of a radical, I kind of want this exponent to match the number that's out here. If I have too few, it's stuck on the inside, it can't get out. If I have too many, then I can kind of break that up into 2 m's or 2 x's or 2 whatever the base number is, and I make this one match the number so that way this guy can get out, and then the other guy is stuck on the inside. And then when I take it out, it gets multiplied to the front of the radical. Let's do another example like this just to show how do you simplify a radical. All right, so we have x to the 8th power inside of the radical. The index number is a 3. In other words, I need this exponent to be a 3 in order to get out of jail, or actually a multiple of 3, and that's going to be what's going on here. So if I relooked at this problem, I would have a cubed root what's on the inside? If I broke x to the 8th power, this would actually be x to the 6th times 2 more x's. Now the reason why I say x to the 6th is because if I was to take an x out, the jailer would take away 3 of my tokens. So I would have an x on the outside. So here's my radical. The jailer's telling me it takes 3 tokens to get out of jail. I took an x out, but I still have 3 tokens right there, and then this guy would have 2 tokens. This guy could also get out of jail. In other words, I could take another x out, and when I take it out, it multiplies to the front. So this would be x times x, which is x squared. This x that's still stuck on the inside of this radical is stuck. He does not have enough tokens, so he would just be on the inside. So my final answer, when I'm reducing this, would be x squared times the cubed root of x squared. That guy is still stuck on the inside. All right, 48. 48 has a 1 power. What is the index? An invisible 2. I do not have 2 of these, so it looks like I'm stuck, I can't get out of jail. However, if I was to break down 48 and list all the things that multiply together to get 48, something interesting happens. A lot of teachers or a lot of students end up breaking this down like a tree, and let's go ahead and do this model. It kind of works pretty well. So you think of the things that multiply together to get 48. So I'm going to say 2 times 24. So if I wanted, I could list this as the square root of 2 times 24. And that doesn't really help that much yet. So I'm going to keep on breaking the 24 down as far as it possibly can, and then I'll list it here and see if that helps me try to simplify this and take stuff out of the radical. So 24 is really 2 times 12. 12 is really 2 times 6. And then 6 is really 2 times 3. Now I think it's a good idea. Let's circle all of these little ends. I don't want to circle the 24 or the 12 or the 6 because I broke them down even farther. I'm circling just the ends. So that way I know 48 actually equals 2 times 2 times 2 times 2 times 3. So I'm going to write this over here as 2 times 2 times 2 times 2. There's 4 of them. 1, 2, 3, 4. So that would really be 2 to the 4th power. 2 times 2 times 2 times 2. 2 to the 4th times 3. That's really the same thing as 48. Now we'll look to try and break things out of jail. How many tokens does it take? Well, there's an invisible 2 right here. So I can take a 2 out. The jailer's going to take away 2 of my tokens. So what's still on the inside? Well, there's still another 2 to the 2nd power here. So I could take another 2 out, so that would be 2 of them now. Okay, all my 2's are gone. What's still left in here? 3. So my final answer would be 2 to the 2nd power, which is really 4. So I'm going to say 4 times the square root of 3. Now, I didn't really need to put the 2 there. I could have left it invisible. In fact, I will. So this is 4 square roots of 3 would be what this simplifies to. I feel like we're kind of starting to get there a little bit. Let's look at another one. Let's pick a big number like 120 maybe. Square root. Let's do a 3rd root this time. 3rd root. Notice that this is a little tiny 3. It's not a big 3. Be careful when you write it. Some people do this, and then it just looks like 3 times the square root. Now you're starting to think it's an invisible 2. So if it's ever a cubed root, try to write it really small and just kind of tuck it up in that corner so you don't get confused. So we're doing the cubed root of 120. Well, let's break it down. So let's break it down differently. Instead of 2 times 60, let's say 30 times 4. That's 120. Or we could have done 10 times 12. In fact, let's do 10 times 12. That's 10 times 12. Okay, now let's break down the 10. Well, that's 2 times 5. And those are ends. I cannot break it any farther, so let's just circle them. What about 12? That would be 2 times 6. Okay, a 2 is an end. What about 6? I can still go a little farther. 2 times 3. Okay, I've got all ends now, so let's rewrite this. This would be the cubed root of, how many 2's do I have? 1, 2, 3, 2 to the third power, times, how many 5's do I have? Just 1. And how many 3's do I have? Just 1. So what can I, air quotes, get out of jail? Just a 2. That is the only thing that's going to get out. So I'm going to have a cubed root. On the outside of this, I'll have 2 times that. How many 2's did I take out? Only 1. I only had enough tokens to get one of the 2's out. And it canceled all of them, so they all got out. Well, I guess one 2 got out, canceled 3 tokens. What's still stuck on the inside, though, is the 5 and the 3. Are they going to get out of jail? No. So now we just simplify it, multiply them back together. 5 times 3 is 15. And so this would be my final answer. 2 times the cubed root of 15. I can't break anything down. They don't have any tokens. I can't get out of jail. All right, that looks pretty complicated. Let's take a peek at that. So I've got the 4th root. In other words, it's going to take 4 tokens to get out of the radical. On the inside, I've got a 3. What's the power of the 3? I need to know that. Looks like an invisible 1. It's not a 7. The 7 is actually connected to the x. So I have 3 to the invisible 1, x to the 7th, y to the 4th, z to the 2nd, m to the 9th. So I'm going to simplify this. What am I able to take out of this radical? Okay, well the 3 is not getting out. It only has 1 token, so it's stuck on the inside. How about the x? I've got 7 tokens, so I'm able to take an x out. So there's going to be an x out here. But when x walks up to the jailer, he hands 4 tokens. There's going to be 3 left over, so I still have x to the 3rd left inside of the radical. Okay, so you got to be careful with that one. How about the y? He only has 4 tokens. He, she, it, whatever the gender is, I don't know. Walks up to the jailer. He only has 4 tokens, so he cashes all of them in, and then the y gets out. There's no more y's left over inside the radical. Y is outside of the radical. What about z? Z squared does not have enough. Our poor buddy z is stuck on the inside. M has too many. In fact, he has so many he can get himself out twice. Not really sure how that works. But if I take an m out, that cashes in 4 tokens. I still have 5. So he can come out again. So there's 2 m's out here. So I have m squared. And my 4, see that? My 4 is kind of starting to meld into it. You got to be careful so I don't get confused. But when I did, I still have 1 m left on the inside. And so I've got an m to the 1 here. I'm going to go ahead and just put a little down tick here so that way I know where it's over with. Now I'm going to rewrite this again. For me, it's kind of ugly, it's messy. I'm going to rearrange it, and I like to always write it alphabetically, A to Z. So with the m, I would actually write the m first. So I have m squared xy times the 4th root of what's still inside the radical. I have a 3, m would actually go next, x squared z, x to the 3rd, z squared, okay? And now it is simplified, if you can call it simplified. This would be a simplified radical. So long story short, when you're simplifying radicals, you need to look at the index number, the tiny little number that's up by the radical, and you're trying to match that up with a power that's on the inside of the radical. If you can get them to match up, it's kind of like cashing in the tokens, and then you can go from there. Okay, I'm going to have a few more videos on radicals. There's a lot we can get into. So if you have questions, check out my other videos. Give this channel a like and a subscribe, and we will see you soon.